All right, so now we are going to move on to section 2.2. This is going to be determining volumes by slicing. So this actually does have a note sheet on the Canvas page. At the very top, you will see a link to, I believe it says note pages, and on there you are going to find all of these for the for the whole class. I believe section 2.1 was the only one that didn't have one. Everything we do from now on is going to have one of these. And the purpose of this is just because I noticed we were wasting a lot of time writing down a bunch of stuff. And so now it's already here. So you can either print these out or, do whatever you've got to do. You don't have to turn anything in these. This isn't the homework. This isn't any of that. This is just to save you from having to write a bunch of stuff down. Okay. So, like I said, instead of writing this, I'll just point at it. And then instead of writing all of this down and going to take a lot of time, I will just read it out and that kind of thing. So then instead, I would just write example number 1 and work it out here so that this up here lets you know which one I'm on, but I don't have to write everything out. So anyway, note sheet, use it, very helpful. Okay, so now I'm going to be working on determining volumes, okay? So I'm going to take this one more step. So finding the volumes of what? That's what this first term right here is, the solid of revolution. What it is I'm going to take a graph, a regular 2D graph, and I'm going to rotate it. So basically what this means is like if I have, like I said, just like a 2D graph, I'm just going to make real basic. Let's say I had this graph from A to B. Let's say it's this region. I'm going to take the region bounded by that graph, and I'm going to rotate it, okay? So sometimes it'll be rotated around the X, which means I'm going to take this graph and just kind of wrap it around it, which is going to make this kind of shape. And it's going to be filled in like this, except it's a 3D shape, okay? So now I am in 3D land where my shapes are going to be 3D. This 3D shape is what we call this right here, a solid of revolution, okay? It may be rotated this way, or in section 2.3, I'm going to see some rotated around the Y, okay? That's what I want to know in sections 2.2 and 2.3 is how to find the volume of this stuff, okay? So before we do that, let's look at a shape we know, a 3D shape we know. Let's do a cylinder. So let's take a cylinder. By the way, y'all are going to see my horrible art skills that I don't have. Let's say I wanted to find the volume of that, okay? So some of you might know the formula for that is pi r squared times h. But let's talk about y, okay? Let's say I take one little slice of this, okay? I'm going to cut this, slice it right here. I slice it, and then I'm going to pick it up and look at this slice, okay? What shape would that slice be if I cut it and looked? That would be a circle, right? Well, think about how I find the area of that. Area of this shape is pi r squared, where this is r. There's my first part of it, right there. Pi r squared right here comes from, that's what the shape of each slice is, okay? But I'm going to do that for the entire height, right? I'm going to slice it 100,000 billion times, which means I'm going to multiply this pi r squared by h, which is my height. That's where I get that from, okay? Again, I slice it and then look at what the slice is. It's a circle, which I can find by doing pi r squared. And then I'm going to do that for the whole height. So let's see how I can relate that to a graph, okay? So let's look at this first example, example number 1. Find the volume of the solid of revolution found by rotating the region bounded between the graph of f of x equals square root of x, the x-axis from 1 to 4 around the x. That's a lot of words. Let's try to break this up and see what they really mean, okay? So the function I'm going to work with is the square root of x. If you remember from pre-calculus or whatever class you had where y'all learned how to graph, the graph of square root of x looks like this. So I'm taking that graph. I'm going to do it from 1 to 4. So 1 can be like right here. 4 can be like right here. And it's bounded by the x, which means I'm just going to stop right here. So that means I'm taking this region right here. And I'm going to rotate that about the x, which means I'm going to rotate it, which again just means turn it around the x. So it's going to make this shape right here. Again, this is a 3D shape. I just can't draw. This is a 3D shape, and I'm finding the volume of that. And I'm going to use the same thought process. This is example number 1. This is the same thought process I did a while ago. By that, what I mean is I'm going to slice it. I'm going to take a slice right here. If I sliced it and looked at that slice, the shape is going to be a circle. And I know that because I rotated it, right? So it's like a round shape. So again, area of this is just pi r squared. But let's think about what r is for this case. Remember, r is half of my length right here, right? So in this case, if I drew this right, which is, it's not very good, but if I had, r is going to be my height of the graph. Does that kind of make sense? So r, again, is half of this length, which means it's going to be the height of the graph. And think about it. The height of the graph right here is my line, and my line is square root of x. So the area for each slice is pi times the square root of x squared. Again, because that's what my graph is, right? We're dealing with the graph of f of x, and f of x was the square root of x. So r, in this case, is the square root of x. Square root of x squared is just x, so this is pi times x. So I'm going to be doing that from x equals 1 to x equal to 4. Therefore, the volume is going to be integral from 1 to 4, again, because that's where I start and stop, of pi x dx. So now I can just work this out. Pi is a constant, so I can pull it out front if I want to, if it makes you feel better about it. I like it out front, personally. Antiderivative of x. Remember, this is like a power of a 1. Add 1 would make it 2. Divide by my new power, which is 2, from 1 to 4. Plug in a 4 first. 4 squared over 2 minus, plug in a 1. 4 squared is 16. 1 squared is 1. 16 minus 1 is 15. So the volume is 15 pi over 2. 15 pi over 2. So think about what I did right here, right? I just did pi r squared in here, and my r is the graph. So that is going to be our trick for finding the volume by slicing. That is what we call the disk method here. V is equal to pi integral from a to b of f of x squared. Again, all this is pi r squared. So remember that pi r squared is what this is. Or I could write it like this, as a function in terms of the y. But the key thing here, put like a star right here, highlight it, whatever you've got to do. This can be used if the function is in terms of x and is being rotated around x, or if the function is in terms of y being rotated around the y. If the function is in terms of an x rotated around the y, it doesn't work. Or if it's in terms of a y rotating around the x, this will not work. We'll learn in section 2.3 what I do then. But again, this is only if it's in terms of x being rotated around x or in terms of y being rotated around y. Again, it's just pi r squared. So let's do some more examples from this here note sheet. Example number 2. Let R be the region bounded by the graph of g of y equals the square root of 4 minus y and the x over the y-axis interval from 0 to 4. Use the disk method to find the volume of the solid of revolution made by rotating R around the y. So let's think really quick first before I start this. If it did not tell me what method to use, how might I know I want to use the one, right? Well, the reason is because it's in terms of a y being rotated around y. So I'm going to use this, okay? And again, it's just pi r squared. So easy enough. The volume is going to be equal to integral. It says from 0 to 4. So 0 to 4. Oh, I forgot pi out front because it's pi r squared, right? The function here is the square root of 4 minus y. So square root of 4 minus y squared dy. And that's it. That's all I've got to do. Pi f of y squared. So let's work this out. A square root squared cancels out, so that's going to just be pi integral from 0 to 4. Again, square root squared cancels out. 4 minus y dy. Now I can take the antiderivative. Antiderivative of 4 in terms of y gives me 4y. My power here is a 1, so add 1 would make that y squared over my new power, which is 2, from 0 to 4. So first, plug in a 4. 4 times 4 minus 4 squared over 2. And then minus, plug 0 in. 4 times 0. Minus makes that plus 0 squared over 2. It'll be equal to pi times 4 times 4 is 16 minus 4 squared is 16. 16 over 2 is 8. 4 times 0 is 0, so that term's out. 0 over 2 is 0, so that term is also out. 16 minus 8 is 8, so the volume is 8 pi. Once again, it's just pi r squared, where r is the function. Let's do example number 3. Find the volume of the solid of revolution bounded by the graphs of f of x equals x squared minus 4x plus 5, x equals 1, x equals 4, rotated around the x. So again, this is a lot of words. Let's just try to break it down. X equals 1 and x equals 4 are horizontal lines, which basically means what this means is it's just trying to say where it starts and where it stops. So even though it sounds like more stuff, it's not. It's just meaning it starts at x equals 1, ends at x equal to 4. So do this one the same way. Volume equals pi integral. Again, it's starting at 1, stopping at 4. So 1 to 4 of the function squared. And the function here is x squared minus 4x plus 5 squared dx. Really the only quote-unquote hard part, it's really not hard, it's just a little extra work, is squaring this out. Because remember, to square stuff, you have to multiply it by itself. So when I square that, I've got to do x squared minus 4x plus 5 times x squared minus 4x plus 5. The reason I didn't have to up here is because it was a square root, and a square root squared, they cancel out, right? I don't have that here, so I have to actually square it out. X squared times x squared is x to the 4th. X squared times negative 4x is negative 4x cubed. X squared times 5 is 5x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 4x is positive 16x squared. Negative 4x times 5 is negative 20x. 5 times x squared is 5x squared. 5 times negative 4x is negative 20x. 5 times 5 is 25. Excuse me. Combine like terms. X to the fourth. Negative 4x cubed, negative 4x cubed. That's all my cubes. So that's negative 8x cubed. 5x squared plus 16x squared is 21x squared. Plus 5x squared is 26x squared. Negative 20x minus 20x is negative 40x plus 25. So this is going to be pi times the integral from 1 to 4 of x to the fourth minus 8x cubed plus 26x squared minus 40x plus 25 dx. Take the antiderivative of that. X to the fourth, add 1 gives you x to the fifth, divided by my new power, which is 5. Same thing here, x to the third makes it x to the fourth, so minus 8, x to the fourth over 4. Same thing here, plus 26, my power becomes 3, x to the third over third, minus 40x, add 1 makes it 2, so minus 40x squared over 2. And then plus 25 makes this just plus 25x from 1 to 4. What's really nice here, 8 over 4 can simplify because that's just 2. 40 over 2 can simplify to just be 20. That's helpful. So that's going to be pi. Plug in our top bound first, which is 4. So 4 to the fifth over 5 minus 2 times 4 to the fourth plus 26 times 4 cubed over 3 minus 20 times 4 squared plus 25 times 4, and then minus, plug in a 1. So minus 1 to the fifth over 5, minus makes that plus 2 times 1 to the fourth, minus 26 times 1 cubed over 3. I ran out of room, so I'm moving on to the next line. Minus makes that plus 20 times 1 squared minus 25 times 1. And if you work all of that out and do all of it out, what you end up with is 78 pi over 5. One thing I will say about Cal 2 is get in the habit of working with numbers that aren't pretty because we're going to see a lot of those where it's a lot of this like 26 over 3 stuff. So make sure you practice that a lot. Just like this, even though I didn't go through every step to show you how I got this because I ran out of room, you should pause this and work it out and make sure you can get this. Okay, that's a big deal because like on a test and that kind of stuff, I'm not going to be here to help you. So make sure you know how to get that. This next example takes it one step further. So let's look at example number 4. Hit pause if you need to write this down. Example number 4 says, find the volume of the solid of revolution bounded above by f of x equals square root of x and below by g of x is equal to 1 from 1 to 4. So let's look at that one. Let's look at what changed there. So the difference here, for number 4, is that I'm saying it's bounded above by square root of x and below by g of x equals 1, which is this graph. So what this means, if I'm going from 1 to 4, notice 1 is where they meet and 4 is like somewhere over here. I'm taking this region right here. So the difference is that I'm not using the whole thing like what I have been doing, right? I want only this little piece of it right here. I don't want the whole thing. So how would I handle that, right? Well, notice if I just did the pi integral from 1 to 4 of square root of x squared, that would give me for all of it, as if all of this was shaded into and for the whole thing. So then after that, I want to take out how much I gain from doing this, right? I want to remove this. So that would be minus, now find the volume from this little piece here. Well, that would be pi r squared, so pi integral 1 to 4. My r here, the function is 1. So 1 squared dx. So again, start with the larger piece, which would give me the whole thing, but then I want to take away what I gain from this. The radius here is a 1 because the straight line is y is equal to 1, right? Because that's what it says right here. So I'm going to use 1. So the idea here is I want to do the outside part and then minus the inside part. That's what the washer method right here says, okay? This is the outermost part minus the smaller part. Same thing here, if it's in terms of the y, do the same thing. So let's work this out. Square root of x squared is just an x, so this is pi integral 1 to 4 of just x dx minus pi integral 1 squared is just 1. Antiderivative of x, add 1 gives us 2, so x squared over 2 from 1 to 4 minus pi. Antiderivative of 1 is just x. So plug in a 4 first, it's going to be pi 4 squared over 2 minus, plug in a 1 squared over 2 minus pi times, plug in a 4 minus, plug in a 1. 4 squared is 16, 1 squared is 1. This one isn't hard, 4 minus 1 is 3. 16 minus 1 is 15, so this one gives me 15 pi over 2 minus 3 pi. Get a common denominator, which would be 2. So 15 pi over 2 minus 6 pi over 2. 15 minus 6 is 9. So 9 pi over 2. So when the region is bounded by two different graphs, we use the washer method. Notice here both of these had a pi, so I could have just pulled out pi out front, which is what they did here. And also, since I'm saying this minus that, I could have made it 1 by just subtracting them here. So either way, whatever works for you works. So let's use this again on example number 5. Find the volume of the solid of revolution formed by revolving the region bounded above by the graph of f of x equals x and below by the graph of g of x equals 1 over x from 1 to 4, and we're rotating it around the x. So let's do that. It tells us that it is bounded above by the first one, so that helps us out. Pi integral, it says from 1 to 4, so that's what I'm going to do. F of x squared means my top graph squared. My top graph, it says, is x. So x squared minus the bottom graph squared. That says the bottom graph is 1 over x dx. And so now I've just got to work that out. So this is going to be pi integral from 1 to 4. X squared is just x squared. 1 over x squared. 1 squared is 1. X squared is x squared. So this is 1 over x squared, which we can write as x to the negative 2. Again, because that's 1 over x squared, which we can write as x to the negative 2. So now take the antiderivative, add 1 would give me a 3, then divide by my new power, which is 3. Same thing, add 1 is going to be negative 1 over my new power, which is negative 1. Let's simplify this because it looks really bad. X cubed over 3 is fine, but this one, dividing by negative 1, what that does is it's going to change the sign. So that's going to become plus, and then x to the negative 1 is 1 over x. So now plug in my top bound. 4 to the third over 3, plug in still plug it in, 1 over x, 1 over 4, minus, plug in the bottom bound. So 1 cubed over 3. excuse me, minus 1 over x, so 1 over 1. That's going to be pi times 4 to the third is 64, plus 1/4. 1 cubed is just 1. 1 over 1 is just 1. The common denominator here would be 12. So we need to multiply this by 4, which would give you 256. You need to multiply this by 3. You multiply this by 4. You need to multiply this by 12. 256 plus 3 is 259. 259 minus 4 is 255. 255 minus 12. I was trying to be really smart and do it all in my head, but let's be real. 243. Those have a common factor of 3. Divide by 3 and you get 81 over 4, which is as simplified as it can get. So 81 pi over 4. So the key thing there for the washer method is that if you have two graphs, just do the top graph minus the bottom graph. That's all I do there. Example number 6. Find the volume of a solid of revolution formed by revolving the region bounded by the graphs of f of x equals square root of x and g of x equals 1 over x from 1 to 3 and rotating it around the x. So same thing here, except the difference is they don't tell us which one is on top. So I've got to see that again, just like we did earlier, or I guess I should say in section 2.1. So I got to see which one is on top. First thing is I've got to see if they cross, so that if they switch at any point. So to do that, set them equal to each other. Square root of x equals 1 over x. To get rid of the square root, let's square both sides. Square root squared is just x over 1 over x squared is 1 over x squared. Now I can multiply that by x squared. So multiplying by x squared will cancel out here. That gives us x cubed equals 1. Take the cube root of that, and you get x equals 1. So they only cross at x equal to 1. Since that's where my region is going to start, that's okay. I don't have to worry about them switching, because from 1 and then on, the same one is going to be on top. So I'm good there. So now I just have to know which one is on top. So pick a number between 1 and 3. Let's use 2. F of 2 is going to be the square root of 2, which is about like 1 point some stuff. Whereas, like, if I want to be specific, let's see. Square root of 2. Do 2 and then do the square root of it. It's like 1.4. It's about 1.4. Whereas g of 2 is 1 over 2, which is 1.5. So, or sorry, I almost made a huge mistake there. 0.5, which either way, or actually now means that f of x is on top, because 1.4 is higher than 0.5, right? So the top graph is going to be the f of x. So when I do the volume, it's going to be pi integral. The region is from 1 to 3. My top graph, as I just said, is the f of x, which is square root of x. So square root of x squared minus the bottom graph, which is 1 over x squared dx. So luckily this is a lot like one we have already done. So this is just pi integral 1 to 3. Square root of x squared is just x. 1 over x squared is 1 over x squared, which I can write as x to the negative 2. Take the antiderivative, add 1 to the power, makes it x squared over my new power, which is 2. Minus, do the same thing here, add 1 makes that x to the negative first over negative 1 from 1 to 3. Looks really bad, so let's try to clean it up a little bit. X squared over 2 is fine, but I can make this plus, because dividing by the negative 1 is like making it positive. So plus, and then x to the negative 1 is 1 over x. Plug in our top bound first. 3 squared over 2 plus 1 over 3. I forgot to write them right here. And then subtract, plug in the bottom bound, 1 squared over 2 minus 1 over 1. 3 squared is 9 plus 1/3. 1 squared is 1, so minus 1/2. 1 over 1 is just 1. Common denominator there is 6. So we need to multiply 9 by 6, which is 54. Plus, need to multiply this one by 2. So that's going to be 2 over 6. Need to multiply this one by 3. So 3 over 6. Need to multiply this one by 6. 54 plus 2 is 56. Minus 3 is 53. Minus 6 is 47. So the answer is 47 pi over 6. So I said this a while ago, but just so that I'm clear again, make sure you can do all of these on your own. Even though I'm showing you how to, just make sure you can also do them without my help, because again, on a test, you're not going to have my help. As I was saying all that, I realized I forgot the over 2 right here, because it was 3 squared over 2, so it should have over 2, which would have meant I had to multiply this by 3, which would make this 27. 27 plus 2 is 29, minus 3 is 26, minus 6 is 20. 20 over 6 reduces the 10 over 3, so this should be 10 pi over 3. Which is why you should make sure you can do these on your own, because I am a human too and I can make a mistake. So make sure you are working on these on your own as well as try to watch me do it. All right, so for example number 7, there's going to be a little bit of a change, okay? So example number 7 says, find the volume of the solid of revolution formed by revolving the region bounded above by f of x equals 4 minus x and below by the x from 0 to 4, but this time it's rotated around the line x equals -2. Really quick, that is a typo. It should say y equals -2. I apologize for that. And the importance is huge here, okay? Because the reason I want it to be y is because this would be a horizontal line, which is what I want, right? If it's a function of the x, it should rotate around the x. So I want it to be a horizontal line like x is, right? If I had left it as x is equal to the -2, that would have been a vertical line, which would make it rotate around the y, which I don't want that, right? So that's a big deal. This should say y right here. Sorry about that. Make a note of that. So the difference here is normally on my xy plane, I'm rotating around this line, right? But this time I'm rotating around, -2 is like right here, I'm rotating around this line. So what does that do? 4 minus x is going to look like this. It's going to be a line like this. My region is this right here. So rotating it around this line instead is going to cause a gap, right? So I have to account for the gap, okay? So how I'm going to do that is in my head, I'm going to move this whole graph up so that this dash line lines up with the x, because I know how to handle that, right? That's what we've been doing. So I want to, in my head, move everything up. So moving this up right here doesn't really do anything, but what it's going to do is it's going to change this graph. So it was 4 minus x. That's what it was, right? But I'm moving it up. I've got to move it up 2 places, which means I'm adding 2. So instead, I'm going to be looking at the graph -x plus 6. Okay, again, because I want to move it up 2 places because my rotation point has moved by 2 places. So I'm moving it up 2 places, so I'm going to add 2. Okay. What that's also going to do is it's going to move this gap, instead of being from -2 to 0, and I move it up 2, it's going to be from 0 to 2. So it's going to look a lot like one we did a while ago where I'm going to have a gap right here, starting at 2. Okay, so what I'm going to do for number 7, keeping all of that in mind, volume is going to be equal to pi. Again, we're going from 0 to 4, right? 0 to 4. So again, my top graph, I'm moving it up 2 places because I'm moving it 2 places. So this is going to be 6 minus x squared minus, and then I'm putting a gap there at y equals 2. So 2 squared dx. This is how I'm going to handle that. Again, because it was originally like this, but I want to move it up 2 places, so now it's going to look like this, where there's a gap right here. Okay, this is the x-axis. This is the x-axis here. I'm moving it up, and this horizontal line right here is at y equals 2. That's where I get this 2 from. And the reason I have a 6 right here instead of a 4 is because I moved my graph up 2 places. So it was originally at 4, moving it up to put it at a 6. If that doesn't make sense, let me know, okay? No problem. It won't make me mad or sad or anything. Let me know, okay? So now let's work this out. Pi, integral from 0 to 4, 6 minus x squared. Again, we have to square it out the long way, just like we did a while ago with this guy. Square it out the long way. 6 minus x squared is x squared minus 12x plus 36. Again, make sure you know how to get that, okay? 2 squared is 4, so this is minus 4 dx. Combine like terms. X squared minus 12x, 36 minus 4 is 32. So now take the antiderivative of that. This becomes x cubed, divide by the new power, so over 3. This becomes x squared, divide by the new power, so over 2. This would just be 32x from 0 to 4. This is really nice because 12 over 2 is just 6. So this becomes pi times, plug in 4 first, 4 cubed over 3, minus 6 times 4 squared, plus 32 times 4, minus, plug in a 0. What's really nice about this is all of these are just going to end up being 0, so that's really helpful and nice for us. 4 cubed is 64. 4 squared is 16. 16 times 6, I believe, is 96, but I just want to check myself. 96, so minus 96, plus 32 times 4 is 128. Zeros all over here, so that's good. The common denominator here would be a 3. So if it helps, we can go ahead and do this. Negative 96 plus 128 is going to be 32. So plus the 32 there. Common denominator is 3. 32 times 3 is 96. 64 plus 96 is, carry the 1, 7, plus 9 is 160 over 3. So again, the part that normally trips everybody up is just the arithmetic part. The calculus stuff isn't too bad. Make sure you are okay with this stuff. Okay, that's what's going to cause you the most grief, simply because it's probably been a long time since you've had to deal with the fractions and everything. So make sure you can do all that. Last example for this section is example number 8, kind of the same thing. Find the volume of a solid of revolution formed by revolving the region bounded above by the graph of x plus 2 and below by the x from 0 to 3. But this time I'm going to rotate it around the line y equals negative 1. Same thought process here. So since I'm adding a step of 1, I've got to move everything up 1 place. So instead of this being x plus 2, it's going to end up being x plus 3. And then I'm going to have to subtract my gap of 1 I just made. So looking at example number 8. The volume is going to be equal to the integral. The region is from 0 to 3. My top would normally have been x plus 2, but again, I've got to move it up one place. So moving it up one place makes it x plus 3 squared and then minus. There's a gap of a 1, so take away that 1 squared. Once again, if that does not make sense, please let me know. Don't forget the pi. So it's going to be pi integral from 0 to 3. Do x plus 3 squared. Again, square it out just like we did with this one. Square everything out. X plus 3 squared is x squared plus 6x plus 9. Whoop. Minus 1 squared. 1 squared is just 1, so minus 1 dx. Combine like terms. Pi integral from 0 to 3. X squared plus 6x, 9 minus 1 is 8. Take the antiderivative again. Add a power, or add a 1 here, so that becomes x cubed over 3. Add 1 here makes it 6x squared over 2, and that's just going to be 8x. Again, 6 and 2 make 3. 6 divided by 2 makes 3, so that's helpful. Doing this from 0 to 3. Plug in a 3 first. 3 cubed over 3 plus 3 times 3 squared plus 8 times 3. Just like our last one, plugging in a 0 into all of these is going to make it 0, 0, 0, so I don't even really need those there. So this is going to become pi times 3 cubed is 27. 27 divided by 3 is 9. Plus 3 squared is 9 times 3 is 27. 8 times 3 is 24. Add those up. 9 plus 27 is 36. 36 plus 24 is 60. So the volume is just 60 pi. All right, so again, what we learned here in section 2.2 is only good if the function is in terms of x, rotated around x, or in terms of y, rotated around y. If it's anything else, we've got to use another method we are going to learn in section 2.3. Okay. Once again, if any of that does not make sense, let me know.